Let's continue working on example 1, which discusses population growth. We are starting from part C here, which says find an expression for the number of bacteria after T hours. So for this question, we're basically taking our results from parts A and part B and just putting it together. So for part C, our general formula is P of T is equal to some constant times e to the kt. What we've found that our C is going to be 50 and our K is going to be 1/4 natural log of 64 all times T. So this formula is the general formula for our situation. Okay. Let's look at part D next. So part D says find the number of cells after 4.5 hours. So when we look at part D, we simply need to take T equal to 4.5 hours. And we need to substitute that into our population formula. So we're going to get P of 4.5 is equal to 50 times e to the 1/4 natural log of 64 times 4.5. Okay. And when we plug this into our calculator, we are going to get a value, a rounded value of 5,382. I guess we'll put some units, we'll put bacteria. And I'm going to highlight that answer there. Okay, great. Let's take a look at part E. Part E says find the rate of growth after 4.5 hours. So what we're going to get for part E is we need to take the derivative of P. So this question is really asking us what's P prime of 4.5? And to answer that, we really need to use the chain rule to take the derivative of this function. The outside function is 50 times e to the something, and the inside function is 1/4 natural log of 64 times t. So when I use the chain rule to evaluate that, I am going to get P prime of 4.5 is equal to 50 e to the 1/4 natural log of 64 to the times 4.5. But by the chain rule, I have this multiply by this extra constant 1/4 natural log of 64. And when I pop this number into the calculator, I get 5,595.5 bacteria per hour. We want to include the units. We want to make sure that we see it's a rate of change. So this is what we get. The final question we have is, when will the population reach 50,000? So what we're going to do this time is we are going to take our general formula, and if we want to find out when we reach 50,000, we just set the left-hand side equal to 50,000, and we just solve for t. So when we go for part F, we have 50,000 is equal to 50 e to the 1/4 natural log of 64 all times t, and we need to solve this. So the first thing we're going to do is we're going to divide both sides by 50. After dividing both sides by 50, this gives us 1,000 is equal to e to the 1/4 natural log of 64 times t. Okay. Then I could take natural log of both sides. I'm going to get natural log of 1,000 is equal to 1/4 64 times natural log of 64 times t. And finally, if I isolate the t, I'm going to get t is equal to 4 times the natural log of 1,000 divided by the natural log of 64. Plugging this into our calculator, we get approximately 6.64 hours. All right, so let me highlight that. And that concludes example 1. Take care, everyone.